Hi everyone.
Okay, so I'm going to create a simple C program here that creates a two-dimensional array. So I'm going to create a directory to store my program. I'm just going to call it 2D array, and I'm going to go into that directory, and I'm going to create a file called 2darray.c, and I'm going to modify that file. I'm going to have my include statements here. So standard input output, standard library. Now lets me do my malloc calls. I'm going to do int main, int argc, which is the number of parameters. I'm going to do char star argv, and that is a array of parameters from the terminal that we're going to put into this if we call this program. We're not actually going to use that, but that's what that means. Return 0 because I have an integer function, and I want to create a two-dimensional array of integers. So let me do an int double pointer of array. So as a double integer pointer for my array, and I want to have a number of columns. And let's say make it 5, and a number of rows. Let's make it 10, and then let me do a malloc call to create memory for my array. So if I do array equals malloc of something, this function here is going to return the address of wherever I have memory allocated for this double pointer right here. Every pointer, you can think of it as pointing to the first index of a one-dimensional array. So I'm going to have a size of, and I want to dereference that pointer once. So this ensures that it's always going to be the size of whatever this points to. So this is a double pointer, so dereferencing it once, this is the size of a single pointer. And that would be if it was just a array with one element, but I'm going to have, say, columns times size of that pointer. So now I have kind of like a whole row of pointers here. It's a one-dimensional array that has enough space allocated for a pointer for every column of my two-dimensional array. And now I actually need to allocate space for the other dimension. So I'm going to do for int I equals 0, I less than columns, plus I, and I'm going to do array I. So I'm dereferencing it once there, so now I'm looking at the single pointer. And I'm going to do equals malloc, and I'm going to do rows times size of, and I'm going to be referencing this thing I just put in, array I. And you can see this is going to be the size of an integer because this right here is dereferenced once, so that's a single. This would be a single pointer. We're dereferencing it again, so it's going to be the size of an integer. And then we have row many of them. So that should give us enough space to store an integer at every index here of our array. So now what we also want to do is we want to keep track of our malloc calls and our free calls. Every time we do a malloc call, we want an equivalent free call, and we're going to do them in reverse order. So I'm going to do free I equals 0, I less than columns, plus I. And I'm going to do, actually, sorry, this is a for loop. For that, and I'm going to do free array I. So that should free all of the stuff that I allocated here, because I'm doing the same kind of loop. And then I also need to, of course, free my double pointer right there. And then to avoid a dangling pointer, we can make sure that we have our pointer here pointing to null. Okay, so that should cover all of our memory allocation and deallocation. And then we need to actually print our array to the screen. So let me create a for loop. It's going to be a double nested for loop. And I want to go through each row, and I'm going to want it to print a number that increases as it goes along each row. So it's going to be like 0, 1, 2, 3, 4, and then maybe the next row it'll be 4, 5, 6, 7, 8, 9, something like that. So I need a value here actually too. Int value equals 0, and I'll just increment that every time. So let's see, 4, int I equals 0, I less than rows, plus plus I. So I'm going through every row. And then I'm also going to, at the end of every row, I need to create a line break. So I'm going to do printf my line break. And then within each row, I need to print everything for every column. So I'm going to do for int j equals 0, j less than columns, plus plus j. And then I need to print f. We could have up to 3-digit numbers maybe, so let's do a %3d. That makes sure that each number is going to take up 3 spaces, so they're all aligned really nice and pretty. And I'm going to do array. I think this should be ji, because we've got the columns here. So here we allocated our column. So each one of these is our column, and then we've got. I don't know. I think that's right. Let's see. And then, oh, I forgot my parenthesis over here. And parenthesis. I don't actually have any numbers assigned here. This is a print statement. But I can copy this because this is the basic format of what I'm going to do. I'm going to actually assign a number to each one of those integers. Oops. No. So array ji equals, let's say, value plus plus. Okay, so in theory, this should work. Let's try and see what happens when I compile, see what errors I've got. The output file, I'm just going to call 2D array. Aha, so no errors, which is pretty interesting. So let's try, see what happens if I run it. And this is what I expected, what I was hoping for. So now let's check to see if there's a memory leak. So I'm going to run valgrind like that, and this says we've got 7 allocs and 7 frees. 1264 bytes were allocated, all heap blocks were freed, no leaks are possible. So that means we did good with the memory allocation and deallocation. You always want to run your programs with valgrind after you are done before you turn it in to make sure you've got no memory leaks going on. Or if you're running into issues, it's good idea to check with valgrind, see if we've got memory leaks, because you can have some unexpected behavior. I can demonstrate what will happen. Say like if I forget to free my double pointer here, then if I rerun this again, then now I've got 40 bytes are lost in a leak because I didn't free my double pointer. And if we look at our double pointer, it's this malloc call right here. So we have columns times size of the single pointer. So if our pointers are each 4 bytes, and they're each 8 bytes for our 64-bit system, and we've got 5 of them, 8 times 5 equals 40. That explains our loss here. You can also run valgrind with leaks checks equals full, or with -s to see more information about the errors. Sometimes it'll tell you a little bit more about what's going on. But yeah, this output can help you for sure finding your memory leaks. You might have to use print statements also to see where things run if you're getting like a segmentation fault error or something else. But hopefully this walkthrough helps you with creating arrays and using valgrind to check for memory leaks.